Welcome to Brain Vision.
We begin this question by drawing the forces that are acting on our system. So, the gravitational force acts on the crate. Then, there is a force that the floor exerts on the crate, acting on that crate. At the same time, the gravitational force acts on the person. And then, the crate exerts some force on that person. So, these are the forces that are acting on our problem. Then, to solve the problem, we have to apply Newton's second law. So first, let's apply the Newton's second law to the crate. So, the net force acting on the crate is equals to the mass of the crate times the acceleration of the crate. Note that the crate is standing still, so it's not moving. Therefore, the acceleration is equals to 0. Let me choose my referential as being that everything that is pointing up is positive and everything that is pointing down is negative. In this setup, the net force acting on the crate is equals to minus the weight of the crate plus the force that the floor exerts on the crate minus the force that the person exerts on the crate, which is equals to the weight force of this person. So minus the weight of the person, and this is equals to 0. Therefore, the force that the floor exerts on the crate is equals to the weight of the crate plus the weight of the person. And this is equals to the mass of the crate times the acceleration of gravity plus the mass of the person times the acceleration of gravity. So considering that the acceleration of gravity is equals to approximately 9.8 meters per second squared, we get that the force that the floor exerts on the crate is equals to 35 times 9.8 plus 65 times 9.8. This results in a force exerted by the floor on the crate of 980 newtons. This is the force that the floor exerts on the crate. Now we apply Newton's second law to the person. So now applying to the person, we get the following. The net force that is acting on the person is equals to 0 because the person is standing still, so its acceleration is equals to 0 because it's also not going to move. And there are two forces acting on the person. One force is the force that the crate exerts on the person, and the other is the weight of the person, which is negative because of my choice of referential. This is equals to 0. Therefore, the force that the crate exerts on the person is equals to the weight of that person. That is given by the mass of the person times the acceleration of gravity, which is equals to 65 times 9.8. And this gives us a force that the crate exerts on the person of 637 newtons.